Okay, for example 43, paying attention to our instructions, solve the following equations for theta, where theta is between 0 and 360 degrees. This means two things. Use calculator in degree mode. Let's go ahead and look at that. Mode button is the second column, second row. We're going to arrow down. It says radian, right arrow to degree. Where it's bold, press enter, and dark. And second mode will give you back to the home screen. So we're ready. We're going to solve using cosine. We're not going to change this to x for this time. We're not going to be intimidated. We're going to look at this directly and solving for cosine. We've definitely had enough experience. So Algebra 1, I'm doing addition and subtraction first. We get 3 cosine theta is equal to -2. Divide by 3 on both sides to undo multiplication. And we get cosine theta is equal to -2/3. Now this is tricky on how to respect the negative sign. When we look for theta, because we're told to use our calculator with those prerequisites, we're going to say cosine inverse. So theta is equal to cosine inverse, and we want to make sure we are getting that absolute value. Remember, we're looking at the reference angle, and the reference angle means the absolute value. Absolute value of any number is going to give us the positive value. So here, and that'll be our reference angle. Let's get our quadrants in line. Cosine is negative because that's our original. We just have to apply the rule. Cosine of an angle is negative in quadrants 2 because it's left of 0. Cosine is x, and 3. Okay, and we're going to get those rules for 2 and 3. The rules for 2 and 3 will be 180 minus. So to look at this, it would be 180 minus your reference angle. And your reference angle is, and this is tricky, but respect it, cosine inverse of 2/3. Notice that I put in the absolute value, or that positive angle, which would be reflected into the first quadrant. And in quadrant 3, it's going to be 180 plus cosine inverse, because that cosine inverse gives us the angle. And then we just plug and chug. So this is your reference angle. Let's tag it. Reference angle. Okay, and let's do that. So we'll get our 2 values of theta, prepping our workspace. And I put the work up there. And here we go on a calculator. 180 minus second cosine, and 2 divided by 3. Enter. Nice value. That value, again, check to make sure it's in the second quadrant. Second quadrant parameters are greater than 90, less than 180. So theta equals equal to 1. And if you're questioning how far to round to, keep it in tone of the whole packet. And the entire packet said to round 3 decimal places. So we're just being consistent. What's nice about this, we already put it in once. Second enter will give us the exact same value again. We're left arrowing to that minus sign, and we're going to make it a plus because that is the rule for the third quadrant. And again, check your parameters or your restrictions, which third quadrant is 180, greater than 180, less than 270. So 208, and again, we're going to round to now 3 decimal places. Now, before I look, I'm looking, this 9 is going to be affected by the 6 because that's going to make this 1.90. And box in both solutions. So for example, 43b, you should see we have squared, single, going back, we need to factor. Factoring, to review, let's go ahead and make our let statement again. So let sine theta equal y, and then we'll go back to it. So this is going to be 3y squared plus 7y plus 2 equals 0. I chose to go back to the strategy of making an easier problem because factoring is involved, and we really want to make sure you know how to factor. Because everything is positive, this is an easier quadratic equation to factor. Again, reviewing the rules of factoring, you factor the first term. The first term is 3y squared. 3 is a prime number. That means there's only one way to get 3. 3y and y. y, 3 times 1 is 3. Y times y is y squared. Plus signs between all of these because everything is positive. The tricky ones are negative. And 2 is the first prime number and the only even prime number. However, when we factor 2, 1 and 2, the place is where to put the 1 and where to place the 2. So if you know about factoring, when we multiply, it's a multiplication and addition game, but the inside term has got to be 7. So you play with the 2 and say, hey, if I put the 2 on the outside, 3 times 2 is 6. And then in the inside, yeah, that works. So you have to check with FOIL, constantly check with FOIL. So we want to get the 7. So we're going to put 2 out here, and we're going to check again with FOIL and 2 times 1. Okay? Check with your inner and outer. 1 times y is 1y. And outer is 3 times 2, which is 6y. And then you have your addition game that 6 plus 1 is 7, which is your middle term of your trinomial. So now you're ready to, you factored correctly. We checked. We're going to set each factor to 0. And equal. I like the color to show the new step. So 3y plus 1 equals 0, and y plus 2 equals 0. Subtract 1 on both sides. This one is subtract 2, and we get 3y equals negative 1. And this is y equals negative 2. Divide by 3 on both sides. And we get y is equal to negative 1/3, but this is not y again. Going back to this measure, this is the sine of theta, which is equal to negative 1/3. And this one is, I'll just put it over here so it's pretty level. Sine of theta is equal to negative 2. Okay, so we're going to bring this down. And then we're going to go back to our unit circle. Everything is the circle of life. Okay. Just drawing. All right, we have negative sine. Sine is negative and sine is y. So y is negative in quadrants 3 and quadrants 4. Okay, and the second one is dealing with that as well. So we're going to be following the same rules. So quadrant 3 rules, again, are going to be 180 plus your reference angle, which is going to be sine inverse. Now remember, it has to be of that first angle, so we have to take the absolute value. Again, if you need to see it, this absolute value sign, we'll put here. I'll just make sure, I want to make sure you see that we're taking the absolute value. The denominator, we also should take the absolute value of, so I'll just put it in here. And you'll get your answer. Let's put that in. And that is 180 plus second sine, parentheses, 1 divided by 3. Nice. Okay, and check, yes, this again, check your parameters or restrictions, and we have that theta is equal to 199.471 degrees. Let's box that in. And of course, there's another angle for theta, and a rule is 360 minus for the fourth quadrant. Sine inverse of 1 over 3. Again, for people who like to be exact, just put that value in. And we'll put, so I could do second inner again, which I don't mind. I'm just going back to the beginning, and I'm just going to type over, which is 360. And then minus. Enter. And again, there's your fourth quadrant, which is theta equals 340 degrees. Check as you do this. 340 is greater than 270, less than 360. 0.529 degrees. Okay. Looking at sine, cosine, and tangent. One of the fundamental ideas are we're supposed to know this value, the absolute value of sine, it will be 2. This is larger than 1, so the last one is no solution, and you have to know it's no solution. Let's see if the calculator will give us an indicator it's no solution. And just press clear. And let's see, just in case. So second sine. And I'm just going to put in 2, because we talked about the absolute value. Quit no domain. You could put negative 2, will be the same thing. The reason this is larger than 1. All right, so cross this out. This does not exist. We reject it. We reject it. Okay, 44 is changing pace and asking us how many triangles are possible. Angle A is 20 degrees, B is 40, A is 10. It is hugely important that you know the manner in which we draw our triangles. So angle A is opposite side A. Angle A, we have a measure, that's 20 degrees, and side A is equal to 10. Okay, I'm going to put matching pairs in different colors so we can see it. Side B is 40 units of measure, as going to be opposite angle B. And the same thing is in tone for C, which is not even listed here, but we're going to respect it anyway. C is opposite side C. Okay, this question is asking us how many possible triangles. This happens when the angle that is given is acute. Okay, we have to find out these other angles. So we set up our ratio. This ratio that we're using is law of sines. Law of sines works like this. Sine, look at your formula sheet, of A over A is going to equal. Now remember, with algebra, there can only be one variable. We have a side for B, so we have to find B. So it's going to be B, but we need to find the angle for B. And I'm going to leave that in blue, sine of B. Okay, here we go. We substitute. So substituting from left to right, this is going to be sine of 20 over 10 equals sine of B over 40. Cross multiply to solve. Cross multiplying looks like this. I only like to lasso one side so you don't get confused. And that means we do the same thing on the other side. Since we're solving for sine of B, that goes first. So it's going to be 10 sine of B equals, the constant becomes the coefficient. So 40 sine 20. Undo multiplication with division. We're solving for sine B. Okay, and again, these help you with your steps. A number divided by itself is 1. Here is what we're looking for. We are trying to find angle B, using the sine of B to help us. So angle B is going to be equal to sine inverse of whatever this is. So just put it in exactly, copying it so everybody knows exactly. A lot of people take shortcuts when they're doing this on their own, and then they get unsure of themselves. So write it down. Okay, it's clearing out what we had before and putting in exactly what we have. Sine inverse 40 divided 40 sine 20. Close the door for sine of 20. Close the door, it opens the door, close the door. Divided by 10, close the door for the whole angle, and it says quit. That indicates error, that it is error out of the domain, and it means no triangle exists. Technically, it means it's too short after we find it's the sides that were given, or if we look down further, 10, and we had 40. Because A is shorter than the acute angle, it's no triangles. There's two, one side is shorter than the other. They're adjacent sides. So anyway, just do the formula, work it out, and the calculator will tell you the truth. 45, we have to draw the triangle. So going to my triangle, nice triangle here, using my tools. Again, it's all in a matter in which you draw it. A, angle A, 41, putting the angles inside is opposite side A. Okay? Going around, B is going to be opposite side B. And side C, 19.7, is going to be opposite angle C. Okay, so what we're doing, they only want us to find side B. They only want us to find this value right here. So we have to see what we're given. Right away, you should see your first step, which of course is to draw it. So right away for your second step, you have two angles, find a third. And the formula is this: alpha plus beta, or angle A plus angle B plus angle C equals 180 degrees. That we're going to say, well, we're looking for angle C. Angle C is going to equal 180 minus the sum of A and B, minus that sum, which is 41 plus 58. And angle C, put this in your calculator, clearing what we had before. (180) minus, and just put it in parentheses, just like it's written. And angle B is equal to, or angle C is equal to 81 degrees. That's what we record. Box that in so we can find it easily. So let's put 81 degrees in here. Now we're ready to go to find side B. We have to have an angle and a side opposite that angle. So our step C, we're going to use the sine of 81 degrees over its opposite side, which is 19.7, is going to equal to the sine of 58, because we want to find B. The side B is opposite its respective angle over B. There's our variable. Cross multiply to solve. B sine 81 equals, again, a constant becomes the coefficient. Undo Multiplication with division. A number or expression divided by itself is 1. So we get B, 1 on top, 1 on the bottom, is equal to, we just put this in our calculator, which is exactly the way it's written, 19.7 sine, and just don't forget to close the parentheses, divided by sine of 81. Close your parentheses for sine of 81, enter, and our answer is 16.3 decimal places, 91, and the 4 has to change to a 5 because of its neighbor, and this is a side, so we don't put a degree symbol, and we have done what we've been asked to do. Okay, for triangle ABC, ABC, again, label A equals 9, B equals 12, C equals 16. Side, side, side. This is side, 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 and for side, 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 you use law of cosines. Okay, now they could ask you to find all of the angles, but I'm sure they only want you to see one. And if you notice your instructions, what is the measure of angle B? I'm going to highlight angle B because it's important that you know that is our focus. The equation that they give us is for side C. We're going to use and analyze this formula and create one that's going to help us find angle B. Notice the given side C is also the angle, the matching angle you're going to use. So modifying this, we're going to look at this as B squared is going to equal the values that are not here, which is A squared and C squared minus 2A, the same numbers that were being used, which is A and C, and then this is different. This is going to be cosine of B. We're using this formula, modification and perspective, so that we can find cosine of B. So we're going to solve this by substitution. B squared, we're going to say, so this is going to be 12 equals, well, 12 squared equals A squared plus 16 squared minus 2 times 9 times 16 cosine of angle B. Okay, substitute or simplify. This is 144 equals 81 plus, you can put this in your calculator because I'm not sure, so let's do that. $256 minus, again, all of this should be in your calculator, so go ahead and do that. 2 times 9 times 16, 288 cosine B. Okay, let's shimmy this down. And we're going to add or combine our like terms. These two go together, that's a constant. This is the coefficient of cosine x. So just adding here, left to right, this is 144 equals